All right, good evening, folks, and welcome to another episode of vBrownBag. Let me share my screen. You'd think I hadn't done this before. Jeez. Okay, so welcome, folks, to another episode of vBrownBag. This evening, I'm very excited. We've got a special guest on, somebody that I met at AWS reInvent this year. It was our first reInvent back since the pandemic, and Rob and I were able to hang out and chat for a little bit during the during one of the breakouts in the AWS Hero Room. So this is going to be a very fun chat for us tonight. But before we get into it, let me go through a couple of show notes. If you want to get in on the conversation, please either at vBrownBag or hashtag vBrownBag on Twitter. I will be paying attention and I'll be fielding questions for Rob to take care of as we get into onboarding with Kubernetes. If you want to follow him, and I highly recommend that you do, he is at RobCube on Twitter. He is an AWS data hero. He is significantly smarter than I am, so this is going to be super fun. I'm going to ask a lot of dumb questions, and we're going to have.
I don't know.
we're gonna have us some fun tonight. Cool. So with that, Rob, welcome to the show.
Great, thank you. Thank you for having me. I hope that this presentation sort of enlightens you a little bit as to why I think Kubernetes is how it got here, making sure that this is the magic behind it, and making people maybe converts to using Kubernetes with maybe the serverless bandwagon, but maybe not so far as that, we'll see. But either way, but just to let you know, the participants here, I am a deaf individual and I use sign language interpreting. I'm using American Sign Language. And to most people's surprise, it's not standard all over the world. It's very specific to the country. So I use American Sign Language. This is my interpreter, Amelia. We've worked together for several years now, and she is confident in working with me as far as the tech vocabulary and the knowledge behind it. So we make a good team. So I'll go ahead and share my screen. If there's any questions or concerns about the interpreter or me as a deaf person, feel free to type it in the chat and I'm happy to answer those questions.
Wonderful. I'll go ahead and stop my share then, and Rob, take it away.
I need to set it up so I can see the interpreter. Just give me a second. Can you guys see my screen?
Yes, we can see your screen.
Great. So with .NET, I'll do a little bit onboarding of Kubernetes, kind of demonstration, but just to kind of start out, it'll pretty much be parallel facing what you would see as another programming language out there, the good, the bad, and the immutable. So that's kind of Kubernetes in a nutshell. As far as those things are on Kubernetes when you're up and running. It's not always any storage behind it or getting anything destroyed or created, but it's the storage itself is separate from Kubernetes. So when you're running a database, for example, Postgres, suppose you'd have a compute that would be the immutable part, and the server and the storage and all of that other stuff will be safe in that regard. So another hero might could maybe elaborate on that a little bit more. But just going through kind of the lowdown on Kubernetes, the state of .NET, walking through a tour around EKS and AWS Management Console and kind of what that looks like. And then we'll, kind of go through a few gotchas with setting up EKS that I've faced, oftentimes working in the enterprise or corporate world. Some groups, cloud ops or DevOps groups out there might set it up for you, so you might not see it. But however, I've personally implemented it, and it is a lot of work just to share that information. So I'll share a little bit of things that I ran into, and then I'll do a little bit of demo with kubectl and the command line and how to pronounce it, either it's CTL or kubectl. Some people pronounce it. As a deaf guy, it makes no difference, so you can blame the interpreter, whatever she decides to say. I've heard it a few different ways. So some people have got into that a little bit, and I know that they say kubectl, yeah, like hugging, like cuddling, yeah. I like that word, so we tend to use kubectl.
Awesome.
So the Kubernetes, you know, it's trendy for some reason. It seems to be kind of everywhere. It's being talked about a lot out in the industry. People are a little obsessed with it. I think that just, you know, the cloud foundation behind Kubernetes, everyone's kind of picking on every word that they use. And so Kubernetes, it seems to be kind of a passionate thing in the community. It's very scalable, which is nice. As much as, you know, you want it to be, it can be. It's industry decoupling, meaning the systems out there, you know, you can reduce the blast of those things. So if you have one of those systems down, the rest of them and the infrastructure is still up and running. So that's a convenience. You can see that trend with Kubernetes helping out with that in that regard. You can run any programming language on it, which is really great. So you're not limited to having your particular cloud vendor language of choice. For that, it's pretty robust. You can run C#, Python, Ruby, anything you want. So that is one nice benefit about Kubernetes. And then containerization, obviously, as I kind of mentioned, it's hot and trendy in the industry. And it seems to be the cool thing these days. So when I was, you know, just like kind of poking a little fun at Kubernetes, is it orchestration, or is, you know, as far as like scalability and ramping up the number of pods and no pressure, you know, you can ramp them down if you want to save on cost. But if you pull out one of those things, will it totally collapse? So it is more like an orchestration. So that is a benefit as well. It's pretty stable. Once you have it up and running, it's pretty robust and resilient systematically. So that is a benefit as well. So seriously, yeah, what's cool about Kubernetes, right? So the cloud, and you can run it in that fashion, or you can run it on-prem, and it'll look and act like the same versus, you know, depending on which way you plan to run it. It's very transportable in that way. You might want to hire somebody like off the street, and they might not know Kubernetes, but it'll work in, you know, AWS, Google Cloud, any Azure, you know, any other cloud provider. If you set up on-prem, it's the same concept. So that is nice for various skill sets as developers, software developers maybe, who will be, you know, very opinionated about their particular way of doing things and how to work and, you know, do unit testing and software development life cycles and things like that. A lot of developers and QA want to keep that same process. So Kubernetes can adapt to that. If you switch to serverless, you'd have to change a little bit of the workflow, but with Kubernetes, you can do everything as you did before, and it will operate and function in the same fashion. So it seems like the more things are changing, the more things kind of stay the same as far as like operating systems and different versionings with those type of things, your development environments, et cetera. You can keep those all the same. And of course, you know, cloud providers really do like Kubernetes, and because it's a you know, the computing foundation behind it is kind of what drives Kubernetes and helps them out in the community as well. So it's definitely positive. You know, companies will give money for that because it is, you know, if they're a very stable organization, then it's sort of backing all of those good open source projects and incubators to introduce new add-ons to Kubernetes and things like that. So I've seen a fair amount of that. It's, like it said, because it is so stable and because it's part of the Apache Foundation in that way, it operates a very well parallelly. It is, you know, very geeky. A lot of developers want to be involved with it in one way or another to empower the developers too. So that seems to be kind of a trend. So now we'll go over to some of the .NET side of things. You know, bear with me a little bit on this. You know, it's a robust and solid programming language. You know, it's open source. C# is in that way. CF# as well. So it's not going anywhere anytime soon. So I'd like to touch on that a little bit. There's different opinions about .NET, you know, that you see kind of all over in the community. And just have a few of those examples here. Just adding features and, you know, always takes time. Web, you know, changes, Web 3.0. So .NET will eventually catch up to that, if not already. And with this type of stuff, you know, we're always tweaking languages to improve them and whatnot. So that's kind of where those things come into play. The .NET development community has a lot of users. It's very strong, it's strongly supported and produced. So I just have some stats there. Kind of cool. I was playing around with PowerPoint to see what I can make it kind of fancy to zoom in like that. You can see here with the .NET column, as far as programming languages go, there's you know, like no Python. I think there's one Java, number 10 maybe. So there's a few things here. You can see C# is number 12, but you don't see any Node. That's kind of funny. You know, Python and nodes and there's none of that. They're not in the top ranking here, at least not in the top 14. So it's some, you know, pretty popular ones here that you can see on the top here. It's good, good advertisement for that. You know, there's a lot of, I guess you could say, in good company. So you can see here, number 12 is .NET with Postgres. And that's for the entire stack, of course. So just wanted to show that. Amelia, you doing good? Yeah, I'm good. Thank you. So now I just have to tell you a little bit of my journey, how kind of I got here, and show some of my credibility as to why I'm talking about this here today. So this is just a little bit about me. Currently, I work for Solemn Build. I just started working there a little over a month ago. Before that, I was working for S&P Global. And S&P is where I kind of got my Kubernetes chops, you could say. I worked on them there, but now you can see I'm with Slalom. So now my role is a principal architect. So we go to clients and bring their platforms into the cloud and infrastructure, migrating data, making new data platforms and various things, working with data engineering space. I'm deaf, obviously. I have a wife and 3 kids. We just celebrated 26 years of marriage. Well, will be, I guess, in 3 weeks. So I got to think about a gift. So I've gotten into running. That's been a new passion of mine. I started in the middle of 2018. As you can see behind me, I have some of my bibs, my race numbers from, everybody asks me that in meetings all the time. So I figured I'd mention it. I've been a developer for 25 years. So pretty much as long as I've been, you know, married. I don't know if that's good or bad, but we'll start with, you know, the things that I've gone through over the years: Microsoft Access, VB4 and 6, .NET, all of that stuff, relational databases and whatnot. So I have worked back with the old mainframes and all of that stuff. So those were interesting times for sure. But so I've been around and done a few different things over the years. I became an AWS data hero in 2019. And so, so yeah, I think that's the same as Chris, if I'm not mistaken, right? Same year, 2019.
Yes, we both became heroes in 2019.
Yeah, nice. So maybe that was a good year. So now I'll go ahead and talk a little bit about, now that I've mentioned my credibility, of course, I'm going to talk a little bit about EKS. If you weren't familiar with the term, it's Elastic Kubernetes Service. That's just the sign that we use. I guess I should elaborate. Kubernetes, their standard abbreviation, I'm sure as you've seen out there, is K8S. So we sign KH just because the word is so long, and we sign it faster than some people can say it. So that's, I guess, one added benefit. Yay, sign language. But yeah, talking about EKS here, as far as this is kind of your standard Kubernetes diagram, I wanted to give folks a good picture of kind of what each one of those things look like within Kubernetes. I'll go through this as fast as possible, just wanted, not to go too deep into it, but just really, you could have a whole class in this, really. There's a lot of details, but so you might have to look into that a little bit more if you're interested, but I will briefly go over this. So there's each node here stores where, or we call it the pod in this situation. Let me see if I can do something. So the kubelet is each code running that is managing the kubelet communications back and forth between the control planes. So you can see those here. Oops, sorry. I'm clicking too far, fast forward. So those control those different aspects of the control platform. So you can see here the API services, that's where it communicates between the entire Kubernetes dashboard, and you'll have the scheduler, you'll have the database for Kubernetes as a etcd. This here. And then this part here, the scheduler, that is where you're kind of monitoring the pods and making sure that they, CPU and memory usage is not overwhelmed. And if that is ramped up for whatever reason, you can ramp up a series of pods to accommodate that. The scheduler will notify the control plane that they need to have more pods spun up, or, or taken down, depending on the situation. What else? Let me see. What else can I describe here? The manager obviously manages the system. The cloud control, that is where EKS comes in. So you could say GKS, Kubernetes on Google, and AKS with the Azure version of Kubernetes. So those services operate there. So all three of those use and leverage the cloud controller portion of this. So there's, let's say you had two, for example, in AWS. I think that pretty much covers the gist of this diagram. I'll show you for, just an example purposes, and I'll show you some of these instances. Looking for my web browser here. Okay. So I have two EC2 instances here. So now we'll look at EKS. So I can show you a little bit about what I was talking about. So this is one cluster. You can have as many clusters as you'd like, but you can see the different nodes here. There's two. So those are the two EC2 instances that they're set up in parallel. So that happens automatically. I can show you how to create a cluster, just to demonstrate that. When you work with EKS, you always look at the documentation. The reason behind that is because there's a lot of manual work in implementation. I know AWS is trying to improve that. However, you know, they might use Fargate or something like that that's self-managed. You can do that. I prefer to do it in a slightly different way. If you use more agnostic approach, you can move things around to any of the cloud providers or even on-prem if that's where you're looking to do. But everything will kind of match up with EKS and work just fine if you use a more agnostic approach. So let me see here. Okay, so I've already looked at the EKS setup a little bit. This, you know, you can kind of just reframe your mind if you remember this from the halftime show from the Super Bowl this year. So here, let me see what else. Give me just a second. So we have the different tools here that come with EKS. You can use them as an add-on feature. So there's a list of these here, the different ones you can see. Those, you know, you can see like on the workload on the right, you can see that green bar. That's the health status. If it's red, you know, you go and obviously you'll need to fix something. Something had happened in the past where the DNS had gone down and it didn't create a new DNS record. So I remember, you know, it's always kind of anything that's like an outage related thing seems to always be related to DNS. So Kubernetes is very robust. You can kind of point it anywhere and you can take down whatever you may need to in any situation. So there's different tools, different measurements at the bottom, like this last line here, different metrics. So you can track how much pressure the pod has on it and how much pressure the node may have on it. So if you go to the command line, there's different Kubernetes options here. So let me just type this in. That's almost everything on Kubernetes. So you could divide things up into different namespaces if you prefer. So that's where you can have a little bit more organization. If you like that, or if you prefer to have one node and only have that namespace, you can also do that. So most of the time, really, it doesn't matter. It's just personal preference. You can let Kubernetes decide which node has what pod assigned to it and running. So I can show you that here as well. So going into one node, oops, wrong place. You can see the different pods running in this particular node. It says 6 pods. You can see the memory and the amount of stress on it. It looks good at the moment. And if we look at the other node, it also has 6 running, 6 pods running there as well. So this is how you can kind of diagnose things, but you can also go to the command line. So the nodes, here you can see them on the EKS management console. And you can also see how many, are being used in the CPU and memory usage. That's coming from the metric server, for example, or the metric service, sorry. So going into the different EKS, if you want to go externally into it, you go through a load balancer. So that is here. So that's the load balancer control if you want to get into it externally. So I'll do a little bit more in-depth walkthrough shortly, so you can kind of see, but I'm just giving a general overview. You can see the different features here. So there's an AMI from Amazon Linux 2. You can use that. That's an option here. You can see all of the different features. You don't necessarily need, we don't need this, some of these for today's example. With these, those are needed for operating EKS. So they're set up by EKS CTL. So the command line, that's where you're getting those things from AWS there. So the setup is managed in the cluster through the command line as well. So you can also do that. Go back to the PowerPoint. Okay, so I can explain just here a little bit. I left this slide here for kind of a little bit explanation of what I'm doing. So K instead of cube cuddle there. This is what I chose to use. So you can see the different things here. Let me add here. So this, you can do the same setup in your on your system as well if you choose. So they're just typing these in, for example, just to show you, you can make it more, friendly to the people's experience on the command line. But let's say we wanted to see how much memory uses on a pod is happening. So search that. You can see that the pod is on the default namespace. If you want to show all pods, you can do something like this. So all the namespaces, we'll see them pop up here. So that's another option. You can see that there's very little memory usage being used right now, so that's great. So I'd like to kind of also walk through a little bit more of going through the things that I had ran into, that I had caught when I was playing around with .NET. You would need to create a program, doesn't matter if it's Python or whatever language you choose to use. We have developed kind of, I guess I'm just going to say the things that I had gone through after I had implemented and deployed, showing some examples of kind of what my objectives were, what I wanted to do, an API, showing to Swagger for, I guess, what we call today's Open API. And then I wanted to pull the database from RDS through Postgres RDS. So I'll show you kind of what the outcome looked like there. So here I can show you kind of what my goal was. So you can see there's two APIs, and those are REST APIs. And let me pull this up. So doing page sizes here, second page out of 20. I have no financial certification, so this, don't worry about too much about the actual data itself here, but I just made up some pricing and things like that. So this is not real data. just using this for example, playing around with kind of what I wanted to store in Postgres. So that all looks good, seemed like it worked. And now you'll see how we got it there. It's not letting me move to a different window. Let me see here. Okay, so with this, this here is a program in C#. I pulled the data from the database and used a connection string. And that is being hidden. So, you know, with the app key and everything, that's not there for privacy purposes. But all of that information here is being pulled and shown through the API. And then the Docker file here I can show you of how kind of everything is built. It looks almost exactly like if you were using Python or if you were using any other language, it would look pretty standard. Java even would look very similar to this as well. And so I've got the Docker up and running, it's built the file, and then it's put it on the ECR image. So the ECR is where AWS will store all of the containerized images. Pull that up. So I set up a new repo. You fill this out, name it whatever you'd like. Doesn't matter, whatever you want, preference-wise, private or public. And then you'll create repo from here. So I just did it as is, like that, and .NET app here. You can see the images, the different images listed here. So if you have a tag, for example, you can push it out. So let's push one for now. So that command line, you'll do that with your CI/CD process. So you'll have to, you know, everything will be automated there. So you do that in that CI/CD process, like Jenkins or whatever you decide you're using. The new hot one, I think, is called, sorry, the interpreter missed the one, harness.io. That's the one I've seen kind of out and about. So yeah, you can use whatever for that CI/CD process. But I can explain how I got the Docker files, how they were. If we were to push them to ECR and they don't seem to be there, so you can go back and look at the ECR again. On the right here corner, it says push commands there. You can click on that. And now you can see all of these authentication options first with the token-based authentication here. I already did that, so I will copy that, paste it here. And then the next section, because it's already built, it's fine. Then we will grab this. So you can see it's successfully authenticated, which is great. And then we'll need, looks like maybe one of the tags is incorrect. So I changed the tag to 1.4 here. And then you copy that last one to actually push So now it will be pushed up to ECR. So let's take a look. And now you can see tag 1.4 is here. So now I have 1.4. So I noticed the 1.4 there is exactly the same image as 1.2, 1.3. They use a hash for that to determine whether or not it is the correct one. It's grouped together in that way, so that's fine. You can see that here. There's not too much to see on this section. So now we're ready to run Kubernetes, and so I will show you how to get into that. Let me think. Of course, losing my flow here. Okay, let's find it. So now to do the deployment process, we will look here to see what we can pull out of there. So you'll set up a YAML file. There's no way around that. That is a manual step you have to do. Kubernetes, you can get that from Google or Kubernetes website or wherever you want to get it. But you will have to grab a YAML file. So there's two. There's the service and there's the deployment. So the service part of this is where you access your pods or your deployment, and then the deployment section of it is managing all of the pods together. So it's those two work in tandem, so you don't have to worry too much about it. The service is the entry point for, I think it's 8080 port 8080 to get onto the pod itself. So you can see that listed here. So you don't have to memorize all of that unless you're taking an exam. That is a tough exam. CKAD exam, the Kubernetes application development exam. I did not do very well on that one. It is a pretty tough exam. There's no command line. There's no multiple choice. So it's really, like what you see with AWS exams, you really just have to type it all out yourself. And I did everything, but I ran out of time. So, just to get through all the other questions. So that it's tough in that regard. So congratulations to anyone who has successfully passed that one. It's a tricky one. So like I was saying, get into the entry point here in the service level. And then the deployment is where the power is behind the pods and where everything is generated. So now I'm going to, you can see the image. I want 1.4, right? Because that's what we had just created. And again, your CI/CD process will generate this. So you don't have to every time, come in and do all of this. I'm just showing this for demo purposes to see what it looks like manually, so I can demonstrate that. So if you change your image to 1.2, 1.3, 1.4, 1.0, whatever it is to match what we have here. So all of that matches and it looks pretty good. And we'll see if it's finished here. Now we'll kick it off. I'm going to check one small thing first. Just give me a second. Find the right window. So I'm using a tool called K9S. It's cool. It's an open source tool. So I'd gone through all of these like arrows and entry points and access, describe the pod. I was kind of curious what the picture of the pod looks like. So there's different things in here that you can use. You can see the picture is the image is 1.2. So we'll use that image. And so if you hold that thought for just a second, you can see escape and go back to this other window. So now I'm going to apply my changes. And it seems like the service, you don't have to change anything, but the deployment you do have to. So we'll look at K9S again, see what it says. So you can see something had changed. You just blink and things show up. So now it looks like it's 1.4. So you see how fast that is, how quickly it swapped out the images. And if you want to set up, let's say 3 pods right away instead of 1, you could do that as well. So if you change this to 3, this will make 3 pods created here. So we'll do apply again, apply our changes. So now you can see 3 pods popped up, and you can see how fast that is. So you can see how setting up those replicas, if you want as new pods, it's as simple as doing that. You can see here that there was another gotcha that I wanted to point out. So now you can see with Visual Studio has support for Dockers. So we'll go through a little bit of that, and I can come back to this slide. But what you can see is the Dockers here. You can pick, where is it? So you can change these to the container, like having it run as a container, just like an everyday program. So I'll change it to running it as a container. And it looks like it might have been broken at some point. It's working again now, maybe, we'll see. But I think that, yeah, we can ignore that for now since it's not working properly. Let's see. So now, which of Linux flavors should we use to push it out to the Docker container, out to our system? So you can, look at this and look at the different versions and the sizing of it. You just would kind of want to pick something that suits your needs. Maybe if there's like a missing library, or you need to add that while you're building in Docker, for example. Show you here. So you can add libraries here and add that to the container if you'd like. So if you notice, though, with all of these options here, you see that Alpine is the only one that's 4 megabytes. The other ones are, different sizes. So, depending on your disk space and what you need, right? So it seems like Alpine is, in general, the winner of what people tend to use most often. And the reason I picked Alpine here to use, you can see here, it's .NET 6.0 Alpine. So it has all the libraries ready, Python libraries with Alpine, as well as varying languages that it has ready built in. You can run and use Microsoft if you prefer. So you can type something like just that. So that, you know, if you're using Alpine, it's going to be a little smaller. So that's why you kind of have to watch out for when you're getting ready to containerize. It's an important thing to note. Just food for thought. So when I was working with EKS, I was struggling on how to get outside access into EKS. That was quite a struggle. I was looking at some of the documentation while I was running into this issue. And you just look at it like tons of documentation, trying to figure out what you need out of this. It seemed like you had to add a tag and a subnet to make it happen. It seemed quite odd, but I could show you. Not in this section. Let me find it. It's one subnet. So I should have looked at it before I set up the call. Let me see. So that's fine. We'll just add a new tag here. So you can set up one subnet. It was a kind of a big gotcha for me because it was a little obscure, following all those instructions step by step. And I'm pretty sure that, you know, I wish it was kind of not part of the setup process, but yeah, that one got me for a while. And then also with this one, IAM role binding, that was another part that was a little tricky, setting up all those roles. If, you know, especially you had an account with a lot of different users on it, for example, sometimes you have to go into Kubernetes itself and set up the role. For the RBAC role as an access controller in Kubernetes, they have their own. So sometimes you have to add that in there as well. So your cloud ops person would be more of an expert in it than like someone like myself. However, you know, with this EKS CTL here, this is programming, what do you want to call it? It's their library. It's kind of a custom fit library for EKS. So that's where that comes in. You can set up a new cluster using EKS CTL as well. So if you go into EKS and then from there, here, the documentation, the get started section, that's installing EKS CTL, kubectl, Helm. Helm is their package manager for Kubernetes. So it walks you through it's all here in the documentation. So you'll install EKS, and then if you want to set up a cluster from there, you can go here. You'll run that command, and then that part took me maybe about 15 minutes, I'd say, 15, 20 minutes before everything was up and running. I could have gone out for a quick run and come back and then checked on it and it would be ready. So that's kind of nice. Not too long of a process. So Apple M1, some of you are a little bit confused about that on my Twitter and kind of what was happening behind that. Apple M1 gotcha is the ARM based, and the Linux world has AMD based chip. So what did we decide to do with that? And what I ended up coming to the conclusion was, uploading the image and the ECR, building, everything was fine. It all turned out fine. But then I realized why it broke shortly after, because this was in the Docker build process. So what I did is I deployed it on the pod, and it has a crash loop back off here. There was something wrong with the pod. So I was looking at it and the logs and everything, and the logs showed this here. Let me find it. So the exe format, meaning that it was up and running, but the format part it didn't like for some reason. So I used my Google foo and did a little bit of digging, and looked like I was able to find a link in the Stack Overflow. It seems like it's always, this can be kind of a pain in the ass. So with that, we faced this problem here. So adding that flag there, so that would force the particular version that we needed. So that was causing an issue and what was breaking that process. So the one that I was trying to run on my machine broke. It didn't like it for whatever reason. So obviously it was in the build section, hence the flag. So it looks like it's still running, figure it out. But either way, going back to this here. So adding that flag, then the pod started working beautifully after that. So I went through the AWS load balancer issue, probably run out of time, maybe save it for another day. But it took the external IP address here. And then containers you can go into individually and debug, kind of seeing what is in the container itself. So you can see here the different pods. Let me grab that other screen. I need to figure out the pod name first so I can pull it up. So you can see these here and all the files that are on the pod. You can look through it and to make sure sort of the containerized view to see that everything is there. And you can check the configuration, making sure that that all looks good. Or maybe your CI/CD got messed up at some point. So you can look at the configuration there and see if everything looks good or not. And then with load testing, this was a fun portion too. So this is running off curl commands. So if you have things running, then you can see it's all running effectively here. And putting pressure on my own computer, so it's fine. Let's see here. Should have run it maybe in another window, but here you can see that it's being created and it's making a new container as I put pressure on it. and that deployment process is happening. So the CPU numbers are increasing, where it's creating a CPU limit that it'll hit there. And when we go above that number of pods, then it will redirect traffic to a new pod, as you can see. So that is using the load balancer, like an ALB through AWS. So it's spreading out the pain points a little bit more, which is nice. So that's pretty much all I had. We can wrap up any questions that may have come in while I was chatting.
So there were a couple of questions up in the thread. Let me scroll up a little bit. There were some questions about the process, but I mean this was a very thorough introduction to Kubernetes. A lot of excitement over K9s. So some of the audience members hadn't seen K9s yet, so they're jazzed to get into that. Folks, if y'all have any questions, please post them in the Q&A. There was a lot of chatting in the chat, as there should be, and so if there's any questions that you want to pose to Rob, please post them in the Q&A. But otherwise, this was fabulous. I thoroughly enjoyed this intro. Okay, well, I think that I mean this was fabulous. I don't think that we have any additional questions that we wanted to get into. A lot of folks are saying thank you. That was a great presentation.
Yeah, I like that. I'm just reviewing some of the chat. Also, Amazon just released the EKS that you don't need EKS to run on the cloud. You can run EKS on your desktop.
Right.
So that's something new as well. Just something I thought I'd mention here. Let me pull it up since just thinking about it. So this, you can run it off of your desktop. This is just using it on your own machine. If EKS is, you want to save yourself some money, you can use EKS distro, which they have put out there now. So that's one option as well.
He's definitely giving everybody in the audience a lot of ideas now.
Definitely, there's a lot you can do. EKS, basically, it's a geeky, fun thing for us to play around with, and so yeah, I think it's exciting. I like the command line and doing all of that. It's super fun for me.
Wonderful.
Yeah, and then also, of course, yeah, K9s is fun. There's some other tools out there, like Lens and some other things, different approaches, but I prefer kind of like, feels like midnight, kind of like that look to it. So that's nice. Yeah. So
and for the folks in the audience that aren't already following him, I highly encourage you to follow him. He's at RobCube on Twitter, and he mentions a lot of this stuff in his Twitter threads. So he's got a lot of fantastic information there.
Awesome.
Cool. All right. Well, thank you, everybody. Thank you, Rob, for coming on. This was amazing. Thank you, Amelia, for interpreting this. This was a really enjoyable process that I hadn't done before. So this was fantastic.
Yeah, sure thing. Thank you. This is all of my thanks to everybody involved. Figured I'd put that up there.
Wonderful. Cool. So folks, we will see you again next week. And thanks for coming on, and have a wonderful evening.